Hey everyone, welcome to the channel. In this video, we are starting our machine learning basic series, and today's topic is handling missing values. So, now in real world data sets, missing data is extremely common. Okay, if you don't handle it properly, your model can give wrong predictions or even make crash. Okay, and so in this video, I will show you what missing values are, why they matter, and different ways to handle them using Python. Okay. So, what are missing values? Missing values are data points that are not recorded or available in a data set. Suppose I am showing you a data set. So, this is my data set. Okay. So, as you can see, this is our missing data. It is missing. These are our missing data. So, we need to fix it. So, why we need to fix it? Suppose if we don't handle missing values, machine learning model may crash. Accuracy of model will be decreased. Analysis will become misleading. That's what it is written. Prevent model errors, improve accuracy, and ensure reliable analysis. Okay. So we will do this using Python. Why we are doing this using Python? Because suppose if you have 50,000 to 1 lakh rows in your data set, so it will become very difficult to handle this using Excel only. Okay. So we will use Python. We will see what are the different ways to handle missing values. Okay. So I will show you the different ways of handling missing values using Python. So for coding purpose, we will use Jupyter Lab. For Jupyter Lab, you just need to download this Anaconda Navigator in your system. In my system, it is already downloaded, so I'm not downloading it. So when you will download it, then simply when you will search here Anaconda prompt, okay, Anaconda prompt. So and then you will write CD and you will just give your file location. I'm giving the file location cd control V enter write Jupyter Lab then again press enter. It will automatically navigate to your browser and it will open Jupyter Lab. Okay, so it is opening. Uh, so you can see it is open in my browser. Okay, I will choose this and suppose I am renaming it. Suppose first and missing value. Okay, okay, enter. First, I will import some required libraries. Import NumPy as NP. Enter import Pandas as PD. Shift plus enter. Okay. Now I will load the dataset. So how we can load the dataset? We can load the dataset using Pandas libraries. Okay. Suppose I'm taking a variable data is equal to in this variable I am loading the data set. The data is equal to pd dot read slash csv and I will simply give the path, copy path. I will put the path. Okay. So for checking my data is loaded or not, we will check first three columns. Okay. Sorry, first three rows. Data dot head three. It will give the first three rows. Head gives the first five rows, so I'm taking three rows on. Okay, shift plus enter. See, my data is loaded, and here are these three columns. So this you can see nan. These are some missing values. We need to fix this. Okay. So what are the we will see what are the different ways to handle this. First, we will check the shape of the data. Data dot shape. Okay. So we can see, here I have written CSV because this file type is CSV. if you have Excel, then you can write here Excel and you can give the path. Okay. So we can see by data.shape, there are 16,598 rows and 11 columns I have. Okay. So I'm checking how many null values, how many missing values are there. So how we can check that data is null dot sum. Okay. So you can see in year column there are 271 missing values. There are two values are missing in journal. Publics are 72. You can see that. So we need to fix this. Okay. So how we can fix that? In notes, there are many ways. We can drop the columns. We can use mean, median, mode, forward fill, backward fill. We will see that. Okay, practically. So, so our first method. Suppose I don't need this column. Okay. Suppose I don't need this column and it has some missing values. So we can just simply drop this column. Okay. How we can drop the column? Data dot drop columns is equal to square braces and give the column name. Okay. Control C and Control V. Okay. And we will write in place is equal to true. In place is equal to true means we are updating the data permanently. Okay. See, I have done this. Okay. Now we will check data.shape. Okay. Data.shape. Shift plus enter. Sorry. Oh, sorry. It is data.shape. Now you can see there are 10 columns only. And here you can see I had 11 columns. Now I have 10 columns. It means publisher column is removed. Okay. Now another way. We can simply drop those columns and simply drop this. So how we can drop it? Data dot drop NN. Okay. Data dot drop NN. You can write in place is equal to true for updating permanently. Okay. I'm not writing it because I have to show you the different ways also. So I'm not writing in place is equal to true. It will like remove permanently the missing values rows. Okay. See, so it has dropped the missing values, missing rows which had missing values in any column. Okay. Now another. Suppose if we see data is null dot sum. Okay. Okay. Then if we write in place is equal to true. Okay, it means it will update the data permanently. Suppose I'm writing it. Now you will see. See, there is no missing values in any column. Okay, we have dropped that. Now another way. Suppose I want to write unknown or zero in place of missing values. Okay, so how we can do that? Data dot fill na write unknown. Okay, shift plus enter. It will replace missing values nan or anything with unknown. Okay, so this is also one way of handling missing values. Suppose now I want to fill by forward fill. What is forward fill? Suppose this is my missing value. Suppose this is my null value. Okay, so I need to fix this. So what forward will do is this missing value will take 33 as its previous value. Okay, so we can do data dot fill. Okay, x is equal to 1. Why we are writing x is equal to 1? X is equal to 1. What x is equal to 1 do? It will update the data horizontally. Okay, it will do the it will update the data horizontally. Okay, x is equal to 1. Data data dot backward fill. Backward fill. What backward fill do? It will take this value, next value. Okay, this will take 30 value. If this is null value, it will take 30. Their next value. Okay, right? X is equal to 1. Okay, shift plus enter. Okay, this is also the one way. This is also the way to handle missing values. And next, suppose I want to do it for a single column. Suppose I want to do backward fill for general column. So how we can do that? Data, take the column, control C, column dot B fill, B fill. Okay, shift plus enter. It will take the next value in its missing value. Okay. Now next, we can do this by using mean, mode, median also. Suppose mean, mode, median is used for basically numerical values. So I have numerical values in year column. So we can do this by year. Okay. So we'll see. Suppose how we can do that. Data, we are taking year dot fill NA in parentheses. Again, we will take data year. So from where we are updating. From year's mean value, we are filling the missing value. So we will take mean. Okay. So what we are doing here, data year, we have taken year column from data. We are filling missing values, fill NA, and from where we are filling missing values, year dot mean. Okay. From mean of the year column, we are filling the missing values of year. So shift plus enter. Okay. Same way we can do this median and mode also. We can simply write here median. Okay. Shift plus enter. And same way we can do by mode. So you all know about mean, mode, and median. So these are the different ways, okay, to handle missing values. These are the different ways to handle missing values. In the next video, we will see how we can handle duplicates value. Okay. Thank you. Hello guys. Welcome to the channel. Today we will discuss how to handle duplicate values. So what are duplicate values? Duplicate values are rows in a dataset that are exactly the same or repeated. What it means? Suppose, suppose I have a dataset and these are its columns. Okay. And let's take this row. Okay. Look at the values in this row. In this row. 25 services, single, high school, no, yes, no. Okay. Look at the values in 11th number row. And now look at the row number 13. It is exactly the same values where it has. Okay. So we just need to drop these duplicate rows. Okay. Why we need to basically drop the duplicate rows? Because see, because duplicate data does not add any new information, right? Because it is already repeated. I have I have already its information. Okay. So we don't need the exactly same rows after it. Okay. It simply repeats the same record again. So we just drop the duplicate rows. Okay. So why do duplicates occur? Data entered multiple times by mistake. Somebody like entered single rows multiple times. Okay, merging data sets incorrectly. Someone is merging the data and by mistake it gets repeated. Okay, so these are the other things it is written. Okay, so how we can handle this using Python? Okay, so for coding purpose, we will use Jupyter Lab as I discussed in the previous video. Please download Anaconda Navigator for using Jupyter Lab. After downloading it, just search Anaconda prompt here. Okay, Anaconda prompt. Yes, Anaconda prompt. Write CD and just give your file location. Okay, it is my file location. Yeah, this is my file location. Control C, Control V, enter. Write Jupyter Lab. Jupyter Lab. Okay, press enter. It will navigate to your browser and open Jupyter Lab. Okay, it's loading. So as you can see, it gets open and I will choose this. And now suppose I'm renaming this. Suppose to handling duplicate values. Okay, enter. Now suppose first we will import some required libraries. Import NumPy as NP, import Pandas as PD, ठीक? And shift enter. Now we will load the data set. I am taking a variable data is equal to td dot read slash csv. Okay. Now just right click, copy path and control V. Okay. Now we will check this data is loaded or not through data.head. It will give initial few rows. Okay, I will take three rows. I have written three. Now shift enter. See, my data gets loaded, and if you have Excel sheet, then you can write here Excel. Okay, and you can give the path of the of a path of your file. Okay, so by the way, I'm giving the data set for every video which I'm using. Now, suppose suppose this data set has many duplicate values. So we just need to basically drop the duplicate values. Okay, and nothing we need to do. Okay, so how we can do that? Data dot drop duplicates. Okay, see, data dot duplicates, drop duplicates. Okay, we will write in place is equal to true. Okay, in place is equal to true, which means it will update the data permanently. Okay, shift plus enter, it will drop all the duplicate value. Okay, now my duplicate values are removed. Okay, so now I want to basically store the refined data. How we can do that? Simple. Write data dot to slash csv, enter the name. Suppose I'm giving some name like refine refine dot csv, or we can write cleaned dot csv. But make sure you will give index is equal to false. Unnecessarily, it will provide your index like this one 0, 1, 2. We don't require this in my Excel sheet. Okay, just write false. Okay, index is equal to false. Okay. Shift plus enter. Okay. Yeah. See. Now shift plus enter. So you can see here clean.csv is downloaded. Okay. So that's all in this video. Thank you. Hello guys, welcome to the channel. Today we will discuss replacing values and changing data types. So what is replacing data? Replace means simple, changing one value into another value in the data set. So why do we need to replace values? We replace data with values are incorrectly filled in our columns. Data is inconsistent. Suppose I want only this male. I have this M also, this male also. I want this only. So we need to fix these things and we need numeric format for models. Suppose we will when we will build machine learning models, then we will need to convert string values into numeric values. Okay, so suppose this is my data set and these are its columns. Okay, suppose this is my gender column and I can see I have female values, M values, male values. Okay, so M represents here male. Somebody is incorrectly wrote M in place of male. Okay, so we need to fix this using Python. So how we can fix this? By Python, we I will use Jupyter Lab for this. For using Jupyter Lab, just download Anaconda Navigator. Okay, in my system it is already downloaded. So when you will download Anaconda Navigator, just type Anaconda prompt. Open it. CD. Now give your file location. This is my file location. Control C. Control V. Enter. Jupyter Lab. Write Jupyter Lab. Press again. Press enter. It will open Jupyter Lab into my browser. It gets open. So I will choose this. I will rename this. Replace. I will suppose give name replace values. Replace values. Values. Press enter. Now right. Now we will import some required libraries. Import NumPy as NP. Import Pandas as PD. Shift plus enter. Now we will load the data set. I am taken a variable data pd.read slash Excel. I have Excel file. So I will take Excel, right click, copy path, paste here, control V, check the data is loaded or not by head. Take first three rows, data.head. Now see my data is loaded and I got my first three rows. Okay. So we have seen we need corrections in gender column. Suppose I have small m and we don't know how many values with small m. So we need to fix this. Okay. So how we can fix this? Suppose first I just need to replace a single m value. Um, I only need corrections in m. Okay. So how we can correct one value only. Okay. So data I will take gender column, gender, dot replace which value we want to replace m, comma, from which value it should be replaced male. Okay, male. In place is equal to true, which means it will permanently update the data. So press enter. Okay, this is a spelling mistake. Replace. Okay, so it is handled. Now suppose I want to handle multiple values. Suppose I have male also, male. Okay, male also. We need to make this like capital M. So how we can handle multiple value? Suppose I am also male also. So we can how we can handle multiple value? Again, I will copy this code C, control V, dot replace. Okay, dot replace. Which values we want to replace? First M value I want to replace. Then I want to replace also s- starting from small m male. Okay, I need to replace these values. From which value we need to replace? From this value I want to replace. Male is starting from capital M. Okay, right in place is equal to true. Okay, now set place enter. Okay, it will be handled. Okay, so this is how we can handle for single value. This is how we can handle for multiple values. Okay, now suppose I want to change this value to a numeric value. Okay, like when we will build machine learning model, then we will do this. So how we can replace this by numeric value? Suppose we can use male as 1, female as 0, as we have only two values. Okay, so we can do this. How we can do this? Data, take gender column equal to, again take your data gender column dot map. I will use map method. Which value I want to map? I want to map male as 1. I want to map female as 0. Okay, shift plus enter. Okay, it will be map. Okay, now we will check our data. Right data. See, this is converted as 1, 1, 1, 0, 0. Okay, 1 for male and 0 for female. See, first three rows are male, so first three rows are 1. Okay, so how we this is how we can handle this. Okay, now we will check how to convert data types. So what is data type? What is data type? Every column has a data type. See, this is our data. This is our string data type, means object data type. Also, we can say string data type. This is our integer data type. This is our float data type. And Boolean means is true false. Okay, true false. Okay. Why we need to change data types? Models require numeric data as it is already I have discussed. Wrong data type can cause errors, improve memory uses. Okay. So how we can do that? Suppose first I will see data.info. It will tell us the data types of different columns. Okay. See, date column has this data type, date time data type, time store ID. This has object data type, quantity has float data type, total price has float data type. See, now suppose I want to change quantities data type as from float to integer. Okay, how we can do that? First, it you can see it has some null value, so we need to fix that values. Then only we can change the data type. But we will fill data, go for your quantity column, quantity dot fill any, okay, fill any with one. Suppose I want to give one for the null values, right? In place is equal to true for getting data permanently changed. Okay. This is a warning. This is not an error. Okay. So now we can change the data type of quantity column. Okay. So you can see here it has uh, you can you can see it has float 64 data type. Now we will change it to integer. How we can do that? Write data quantity quantity is equal to, again go for your data quantity column, quantity. I will choose, I will basically use as type. As type, as type is used for changing the data type of any column. Okay. I will use this int. Okay. I will convert the quantity columns data type by int from float 64. Okay. Now you can see it has float 64. Now I will change this from int. Okay. Shift plus enter. Okay. So now data type is changed for the quantity column. Now I will show you data dot info. See, quantity has now int data type. Okay. So data type is changed for quantity column. So this is how we change the data type of any column and how we can handle our replace values. Okay. So in today's video, we saw how we can replace values and how we can change the data types. So that's all for the today's video. In next video, we will see encoding. Okay. Thank you. Hello guys. Our today's topic is encoding using one hot encoding. Okay. So first, what is encoding? Encoding means simple. Converting categorical means text data into numerical form. Okay. So what is categorical data? Categorical data that represents categories or labels. Okay. See, suppose I have a gender column. I have two types of categories, male and female. I have color column. There are three types of categories I have in this column. Red, blue, green. City, Delhi, Mumbai, Pune. I have these three categories. So these are not numbers. So okay, these are categorical data. Okay. So why do we need encoding? Because whenever we will build machine learning models, machine learning always basically deal with numbers. It does not basically it does not deal with categorical data, text data. Okay. So we that's why we need to convert it into numerical form. Okay. So like we can convert male to zero, female to one, or female to zero, or male to one. Okay. So this process is called encoding. So one hot encoding. By one hot encoding, we just create separate columns for each category. Suppose I have gender column, I have male and female categories, and after encoding, it will give us basically two different columns, gender male, gender female. Okay, so uh, I have a data set. I will show you the data set. So this is my data set. Okay. If you will check in gender column, I have two categories, and in ethnicity column, I have one, two, three, four categories. Okay. Today I will do encoding using one hot encoding for these two columns. Okay. So how we can do? Okay. how we can do using Python. For Python, I will use Jupyter Lab. For using Jupyter Lab, please download Anaconda Navigator. Okay. And after downloading it, search your Anaconda prompt, sorry, Anaconda prompt, write CD, give your file location, Control C, Control V, enter, write Jupyter Lab, and again press enter. Okay, it will open Jupyter Lab into my browser. I will wait for a few seconds. It is open. I will choose this. Suppose I will give some name. Suppose I am giving one hot encoding. Okay, press enter. Then I will import some required libraries for NumPy as NP, import Pandas as PD, shift plus enter. Now I will load my data set. Suppose I have taken data variable for loading the data set, pd dot read slash excel because I have Excel file. I will give you the data set. Copy path. Now control V. Now I will check my data is loaded or not. Data dot head 3. I will check first three rows. See, my data is loaded and these are my three rows, first three rows. Okay. So I have to perform operations of encoding for these two columns, gender and ethnicity. What we will do, I will basically uh, I will basically take these two columns first. Okay. Suppose I have taken a new variable data2 is equal to how we can take a data double square braces and give your column name center, take your another column that is ethnicity, control C, control V. Okay. Now see the data2 is I have taken from data C. Now I have taken these two columns from our data. Okay. So now I will do pd dot get dummies. Okay. Dummies for my data two. What get dummies do? It basically automatically creates new columns. Okay. Suppose I have two categories, gender, male, female. It will create gender slash male, gender slash female. Two columns automatically. This is what getDemis do. For ethnicity, it will create four columns because it has four categories. Okay. So see, shift plus enter. Now, see, I have this gave me six new columns. Two based on gender column and four based on ethnicity. Okay, this is what getDemis do. Okay, this is what getDemis do. Okay, now I will import one hot encoder by which we will do encoding from Scikit-learn. I will I will import one hot encoder. Okay, sklearn dot preprocessing from preprocessing module. I can get I can get one hot encoder. Okay, one hot encoder. Okay. Shift plus enter. Okay. Now I have imported one hot encoder from Scikit-learn. Okay. I will create an object to call one hot encoder. Okay. Suppose this is one hot encoder. So I will just give OXE. Okay. OX is equal to one hot encoder. Copy. Control V. I have created an object to call one hot encoder. Okay. Now I will create a variable AR is equal to for taking an array. Okay. So OXE dot fit transform. I am fitting one hot encoder to data 2. Okay. I will explain this. Fit transform for data 2. Okay. To, to array. To convert this as an array. Okay. So what we are doing here? Fit basically learns unique categories. Okay, what are unique categories? Suppose, for example, male, female, Asian, Latino. These are unique categories. It will learn. Fit. Okay. Transform. Transform means convert them into encoded value. What it means? This is in categorical form. It will convert those into numeric form. 1, 2, 0. Okay. So shift plus enter. Okay. Now I have converted this into array. Okay. Now what I will do, I will convert this into a data frame. So I can make this into a readable form. How we can do that? pt dot data data frame. pt dot data frame for which variable AR columns. I will give all columns name here. Okay, all columns name here. What are my all columns? Control C, Control V. I will give male. Now four more columns. Control C, Control V. Three columns more. Control C. Okay. Two more columns. I'm converting this into data frame. Okay. Control V. Last column. My last column is this. Okay. Control C. Control V. Okay. So I am converting this array into data frame. So shift plus enter. Okay. This is saying I have eight. I am giving six columns in, but it has eight. So what we can do, I can simply give AR. I can only give my variable shift plus enter. Now see, my all columns which were gender female, male, ethnicity Asian, which has true false value after get dummies, or I had categorical values. Now it all has numeric values. Okay, it all has numeric values. I have converted this into numeric form. Okay, so this is how we convert categorical data into numeric data using one hot encoding. Okay, so this is all in this video. In next video, we will see how we can do encoding using label encoding. Okay, thank you. Hello guys, welcome to the channel. Today we will discuss label encoding and ordinal encoding. In previous video, we saw what is encoding and how to do encoding by one hot encoding. Okay, encoding is just converting categorical data into numeric form. Okay, and we have seen how we can convert and how we can do encoding using one hot encoding. Okay, so in today's video, we will see how we can do encoding by label encoding and ordinal encoding. So first, what is label encoding? Okay, label encoding assigning a unique number to each category. Suppose I have a column color and I have three categories in that particular column: red, blue, green. So we will assign label encoder will assign a basically a number to each category. Suppose it assigned red to 0, blue to 1, green to 2. Okay, and what is ordinal encoding? Ordinal encoding means assigning numbers based on meaningful order. Basically, it assigns numbers based on a meaningful order. What it means suppose I have an education column. Okay, so I have these categories in my education column: low, medium, high. And after encoding, low it will assign low to 0, medium to 1, high to 2. Okay. So what is the difference between label encoding and ordinal encoding? Label encoding assigns number without considering order. Okay. It will basically randomly assign numbers to each category, red, blue, green, and it will assign based on order. Okay, ordinal encoding. So this is our data set. We will do encoding, label encoding for ethnicity column. I show you. See, these are my categories. We will do label encoding for this, and I will do basically ordinal encoding for this. These have also few categories, one, two, three, four. So we will do basically label encoding, ordinal encoding for this column. Okay. So how we can do that? We will do this by Python. For basically Python, basically for coding purpose, we will use Jupyter Lab. And for using Jupyter Lab, please download Anaconda Navigator. In my system, it is already downloaded. So when you will download Anaconda Navigator and you will search Anaconda prompt here, Anaconda prompt, cd, control V, sorry, okay, I will open cd and give your file location, give your file location, cd, control V, write Jupyter Lab, press enter. It will open Jupyter Lab in my browser. I will wait for a few seconds. So I will choose this. I will rename this. Suppose I will give some name. Label ordinal encoding. Okay. Press enter. Okay. First we will import some library. Import NumPy as np. Import Pandas as pd. Okay. Shift plus enter. Now we will load our data set. Okay. See. Suppose I will take data as my variable ed dot read Excel because I have Excel file. I will write Excel. So I will give the path, right click, copy path, paste here, control V, and we will check our first three rows by data dot head 3. So my data set is loaded. We will do label encoding for ethnicity and basically ordinal encoding for business unit. Okay. So you got to know what is the difference between these two encodings. Okay. The basic purpose is simple. We will assign categorical data to numeric data. We will convert categorical data to numeric data. Okay. So how we can do that? First, we will do label encoding. Okay. So how we can do that? First, I will import label encoder from Scikit-learn, sklearn dot preprocessing preprocessing import label encoder. Okay, label encoder. Okay, now set plus enter. Now we will make an object for calling label encoder. Suppose I will create ali is equal to just with label encoder. Okay, enter. Now, which column we want to basically, which column we want to fit for the label encode? Which column? And ethnicity because we are converting categorical to numeric data of ethnicity using label encoder. So I will fit this column. Okay, how we can do that? Ali dot fit give your column data. It is the column name ethnicity. Control V. Okay. See, it is fitted. This column is fitted to label encoder. Now I will make a new column so that we can fetch the numeric data from ethnicity column. Okay. Suppose suppose I will take a new column. Control V. I will give some name slash num. Okay. I am converting to num. I have taken that is equal to ali dot fit transform transform. Okay. What I will transform ethnicity column, ethnic column data. Now, okay. So what we are doing here? Fit means I already discussed in my previous video. Fit means it learns the basically unique values. What is the meaning of unique values? See the data. So these are unique values. Asian, Black, Persian, Latino. These are unique values. It will learn unique value. Okay. So what is the meaning of transform? Transform basically convert the categorical data into numeric data. So this is what we are doing by this line. Okay. Now step plus enter. Now we will check our data. Step plus enter. See, I got my new column ethnicity num and it has assigned numeric data for my ethnicity column. Okay. So see here. Okay. This is how we do label encoding for converting categorical data into numeric data. Now we will see how we can convert categorical data into numeric data using ordinal encoder. Okay, so I will use the same data set. but I will do for business unit column. Okay. Now I will import first sklearn dot preprocessing preprocessing import import ordinal encoder. Okay, ordinal encoder. So plus enter. Now, okay. Suppose I will make a object for it also. Okay. Suppose I have ordinal encode, so I will just take OE as my object name. Okay. Just press tab. When you will press tab, it will show you. Now I have created an object to call my ordinal encoder. Okay. Now, first I will see what are the unique values in my business unit column. Okay. How we can see that? Data, take your column, the unique. See, these are my unique values. Okay, these are my unique categories in my business unit column. I will do ordinal encoding for these categories. I will convert these categories into numerical data. Okay, so how we can do that? Okay, so first I will take a variable, separate variable. Okay, suppose I will take data two. Data two is equal to I will take my all basically I will copy this. Okay, I will just copy this. Okay, control C, then paste it here. We are giving this double square basis because it expects 2D data. Okay, so I have given this. Okay, so now, okay, nan also. Okay, so it has some duplicate values. Sorry, null values also. Okay, so it has null. Okay, nan value I will just simply drop. So it has yes. Okay, I will just represent it. Okay, so now I will do this. Suppose OEX. I will take a variable, new variable. I will call my ordinal encoder tab enter null encoder. Now I will do categories. Okay, categories. Categories is equal to what is the category? I have defined my category into data two. So I will just give my data two. Okay, now yes, shift plus enter. Okay, now I have given my categories to ordinal encoder. Okay, now I will make again a new column. Suppose I will give some num business num. Okay, now is equal to again I will do fit transform fit transform, fit transform data, data, which for which column I am doing this? Business unit, business unit. Okay. So I will give this also two braces and two square braces. Okay. Now what we have done here, I'll again I have done fit transform by ordinal encoder to this this column basically for this column of data. Okay, I have fitted ordinal encoder for this column. Okay, fit means it will learn the new category, unique categories. Basically, these are unique categories, and basically transform. It will convert the categorical data into numeric data. Okay, shift plus enter. Okay, so it is showing unknown categories nan. Okay, so it is showing nan. Okay, so suppose so it is considering nan also in this. Okay, nan. So what we will do? We will do. Okay, okay. First we can fill. Okay, first we will fill uh, the business unit column. Okay, first I will fill my nan values. Okay, first I will fill my nan values in this column dot fill n. I will just write unknown. Okay, unknown in place of this. Okay, okay. So it has taken unknown. Now I will do basically it will uh, sorry. I will write in place is equal to true also so that it can permanently change my data in place is equal to true. Shift plus enter. It is just a warning, it is not an error. So don't worry. So now I will give here unknown, shift plus enter, shift plus enter, shift plus enter. Okay. So now I will see my data. So now you will see here new column. See this ethnicity num. I have basically converted categories, categorical data into numeric data from ethnicity column by label encoder, and this is my new column business num. It I have converted categorical data into numeric data of business unit using ordinal encoder. Okay, so this is how we use a label encoder and ordinal encoder for converting numerical data categorical data into numerical data. Okay, so this is how we do conversion of categorical data and categorical data into numeric data using using these two encoders. Okay. So that's all in this video. In next video, we will see outlier detection. Okay. Thank you. Hello guys, welcome to the channel. Today we will discuss outlier detection and removal. So what is an outlier? An outlier is a value that is very different from the rest of the data. What it means? Suppose I have a column weights and most of the values in weights column are lying between 50 to 80 kg. And suppose I got a value of 150 kg. So that is very far from the 50 to 80 kg. So that will be an outlier. Suppose I have a 10 kg data. So that is also very far from the mean value, or we can say the maximum range values. Okay. So why do we need to handle outliers? So outliers can distort mean and variance of the data. Okay. they can reduce model accuracy when we will build machine learning algorithms and we will have complex data which will have outliers, then we will need to fix that. Okay. Some models like linear regression are very sensitive to them. Okay. So, so basically what this diagram is saying. Okay. First, see this red box. Okay. This red box is IQR. What is IQR? IQR is basically those 50% data where maximum values are lying, like here 50 to 80 kgs. So suppose the main values are most values are coming to 50 to 80 kgs will lie here in this red box. Okay, and this yellow line is the mean. Okay, yellow line is the mean. Suppose I am getting a value here in this line between this. Okay, and here. So that will be normal data. So that will normal data. Okay. So now suppose I got my values here very far from this. So that will be an outlier. I got my values here. So that will be an outlier which is very less than our mean values. It is very greater than these values. Okay, so that will be our outliers. Okay, so how we will fix this outliers? So I have two methods. Okay, I will show you how to do it by Python. First, see, method one using IQR. Okay, IQR is equal to Q3 minus Q1. I've already described. So, suppose I am calculating this Q1 minus 1.5 into IQR. So, I got some values like, let's say 15. Okay, by calculating this. Now, I have a value that is 14, which is less than this. Then that will be an outlier. And suppose this is I got value here in 15. So suppose I got value 16. Okay, then that will be a normal value. Okay, but I will get 14, then it will be an outlier. Suppose here I am calculating maximum. Suppose I got 50, but I got 50, but I have a value that is 51, that is greater than this, then that will be an outlier. Suppose I have value 49, then it will be less than this, then that will be a normal value. Okay, so I will check this and detect this by IPR method and also fix the outliers. Remove the basically I will remove the outliers by IPR method. Okay. Second method we will also see using Z score. Z score, what Z score says, Z is equal to X minus mu upon sigma, where X is your actual data point. Suppose I have data 80 kgs, that is our actual data point. Mu, mu means mean, this one, mean. Okay. Now, sigma, standard deviation. How much data is deviating from the mean value? Suppose this is our mean value and I have value around here. So how much my data is far from this mean value? Okay, so that is sigma. And Z is score, how far a value is from the mean. Okay. So this is sigma basically stand how much data is deviating from the mean. Okay, so that is there is a rule. If Z is greater than 3 or Z is less than minus 3, then that will be an outlier. Okay, so I will see that I will show you how to handle outliers and remove outliers. Okay, so first see the data set. This is my data set. I will check for height and weight outliers. Okay, now see how we can do that. I will use, I will rename. Suppose I will give some name outlier detection removal. I will import some libraries. Import NumPy. Sorry, NumPy as np. Import Pandas as PD. I will import matplotlib and seaborn also data. Those libraries are for plotting graphs. Matplotlib.pyplot as PLT import seaborn as NS. Okay, shift plus enter. Now I will load my dataset. Okay, suppose I will take a variable df is equal to pd dot read csv. I have CSV file. Right click, copy path, control V. I will check first three rows which are of head. Oh, sorry, it's not data. Df. So here are first three rows and my data gets loaded. Now first I will check if there is any null value in my data set or not. Again data and writing. Sorry for that. No, there is no null values in my data set. I will check this by describe. It will give me all columns, mean, num. Okay. So, so it gave me dot describe gave me heights and weights count total 10,000 rows are there. 10,000 rows. Mean of these two columns, standard deviation, mean, and maximum for 25%, 55%, 75%. Okay. So first I will check by plotting a graph if there is a outlier or not. Okay. I will plot a basically box plot for these two columns. Okay. Size. I'm giving up my uh, graph size. You will see the subplot at the first place. Whenever I will plot multiple graphs together, we will use subplot. Okay. I am plotting a box plot, give your data, but which is my data set df y is equal to df, and which column we are calling weight. I will give a title. Suppose I will give weight before. Okay. Now same I will give for height column also. So C control V. I will give this as second place. Give height and give the title height. Okay. Now just write plt dot show. It will plot the graph. See, see, you can see in weight column an outlier is occurring. In height column, there are some outliers at minimum, before minimum also, and after maximum also. Okay, you can see here. So this is confirmed. I have outliers. Okay, so first we will see how we can handle outlier using IQR method. Okay, first I will suppose I'm calculating this Q1. Okay, Q1 df df weight Q1 basically gives 25%, finds 25% of the data, right? Quantile 0.25. Okay, it will give the 25% of the data. Same, I will calculate Q3 also. Q3 right, Q3, and right here 7 point. Okay, okay. So what is my IQR? IQR is equal to Q3 minus Q1, Q3 minus Q1, Q1 50%. So I will calculate this. IQR, I'm calculating for weight, so I am giving weight W. Okay, so don't get confused by this. I will minus, it will be minus Q1. Okay, I will suppose in my IQR. So, so this is my IQR. Okay, now I will calculate lower also on basis of this. Lower means minimum and upper maximum. I will calculate this. Okay, lower W is equal to, what is the formula of lower? Q1 minus 1.5 into IQR, and for upper Q3 plus 1.5 into IQR. Okay, so Q1 W minus 1.5 into IQR. Okay, so this is my formula. I will print this also. So here it is my lower, and I will calculate upper also. That is my maximum. What is the formula of this? Q3 plus, okay, Q3 plus 1.5 into IQR. So Q3, where is my Q3? This is my Q3. Control C, Control V, plus 1.5 into IQR W. Okay, I will print this also. So I got my minimum and maximum. And what I have, what we have learned. See, if value is less than this, less than minimum, then that will be an outlier, and maximum greater than this, then that will be an outlier. What it means then? If I got a value less than 58, that will be my outlier, and greater than 264, that will be an outlier. Okay. So same I will calculate for my height column also. And for height column also, I will give h. I will replace this by height. Replace this by height. Press enter. Now IQR h. I will replace this by h is equal to. I will again replace this by h, h. Okay. I will print this. Press enter. I got my IQR h. Okay. Now I will same calculate lower and upper. Means lower means minimum, and upper means maximum. I will replace this by h, given h, and h. Okay, I got this. Okay, no upper, 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 sorry, height. Okay, I will replace this. So I got my minimum value and maximum value for this. If I have a value less than this, then that will be my outlier. I have value greater than this, then that will be an outlier. So now I will simply create a new variable where we will store the data without outlier. How we can do that? Suppose I have created a variable here. I will store the data without outlier. How we can do that? df. I'm going for df. Okay. Now I'm going for my df weight column. What I'm saying is give me those that weight column. Basically, df IPR will be df basically a df data, but df weight will be greater than or equal to lower means minimum. It should be greater than or equal to, otherwise it will be an outlier. And now weight should be less than equal to upper, right? Upper. Okay, you got my point. What I'm saying, give me the data where weight is greater than minimum, and less than maximum, less than less than maximum. Okay, what I'm saying here. Same for my weight column also. Give me those height. Sorry, give me same for my height column. Give me those height which are greater than minimum and less than maximum. Right? Okay. Okay. Sorry, not mine. Okay. I will simply do chat GPT. I will simply paste what it is saying. Okay. So I will simply copy this. Right. Okay. It has picked my value. Now, so you got my point, right? Now, now I will plot a graph to see whether my outlier is removed or not. Okay. So I'll simply copy this. Simply copy this. Okay. Here I will give height. Sorry, wait. I will write here after, and I will give this because now my data is in this without outlier. Okay, same here, and I will write height after. No, plot the graph. See, outlier is removed. See, see the basic difference between these two graphs. Here it was an outlier. Here I had an outlier. Now see the graph. There is no outlier. Okay. So we have fixed the outlier. Okay, by IQR method. Now we will see how to fix outlier by Z score. Okay. So I have already explained Z squares mathematical expression. Okay. Now I will do this using Python. For performing Z score, I have to import basically stats from SciPy, import stats. Okay. Now works but basically gets very simpler in with G square. Okay. What just I need to write G weight is equal to np dot abs. What is this abs means? This abs is for converting the negative values into positive values. See, we can get -3 also. So just we are converting into positive value. So we will not need to basically do separate coding for minus and plus. I will do this by this one only. Okay. So np dot stats dot z score z score df weight. Okay. Same for height also. Okay. So we are calculating its z score. Z score means we are suppose I got 3 -3. So I can get if my value will be greater than 3 or minus less than -3, then that will be an outlier. Okay. So just we are calculating z score. Okay. Basically what this is doing, this formula. This formula is basically here dot z score. That's why we use Python for machine learning. Okay, we are doing this uh, mathematical expression by this one line of code only. Okay, so suppose I will print this also. Okay, I got this z weight and z height. Okay, now I will basically I will store a store my new data into new variable without an outlier. Like in IQR method, I had df slash IQR where I stored my new data without an outlier. In same way, I'm storing my new data into this but without any outlier. So how we can write the condition? I'm writing give me the df data, give me the df data, but what should be z z weight z weight should be should be less than 3. and and df wait height also height z height should what I'm saying here. Give me the df data exactly, but weight z weight should be less than 3 and z height should be less than 3. Okay. So uh, complete the chat with it. Take this. Yeah, I will copy this. I will take this. Okay. So shift the center. So I have new data. I have plot. I will plot new graph also for seeing that by z square method, my from z square method, my outlier gets removed or not. Okay. So how we can do that? I will simply copy this. I'm simply copying this. I will just remove this and I will just update the new variable. Okay. DFJ image will be some. See, from my z square method also the outlier gets removed. Okay. Okay. So here we can see one outlier is coming. So it didn't work perfectly, but although it basically replaced all the maximum outliers. See, first I had these outliers, this much outliers in height, and now I have only this one. I have also only this one. So so by G square method, it didn't remove one outlier, but although it removed most of the outliers. Okay, so this is how we handle outliers using Z score and IQR method. Okay, so in next video we will see feature scaling using normalization. Okay, thank you. Hello guys, welcome to the channel. Today we will discuss feature scaling using normalization. First we will see what is feature scaling. Feature scaling means bringing all features means columns to a similar scale so that no feature dominates other. What it means? Suppose I have two columns. I have age column in which data lies between 80 to 60 and I have salary column in which data lies between 20,000 to 1 lakh. Okay. So as we can see, salary's value is much greater than age, right? So when we will build machine learning model, then it will give more importance to this salary column because it is much higher than age column. Okay, which is wrong in our case. Both are important for us. Okay, so in that case, normalization comes into play. Now, what is normalization? Normalization is a type of feature scaling where values are converted into a fixed range, usually 0 to 1. But what it means? Suppose I have a data frame in which I have values 10, 20, 30, 40. Okay. Now I will apply, when we will apply normalization to it, it will convert 10 to 0, 20 to 0.33, 30 to 0.66, and 40 to 1. Okay. So this is how normalization works, and this is how normalization scales the data, right? So this is the mathematical expression for basically normalization, where this is x prime. X prime is basically a new normalized value. Okay, and x is your original value, and x mean is the minimum value in the column, and x max is the maximum value in the column. Okay, so for these algorithms, we generally use normalization. For k algorithms, k means algorithm, SVM algorithms. We will see all these algorithms one by one. Then we will see supervised learning, unsupervised learning. Okay. So now, so this is the data set. I will apply normalization to these two columns, height and weight. Okay. So see, I will show you how we can do it using Python. So for Python, we will use Jupyter Lab. For using Jupyter Lab, please download Anaconda Navigator. In my system, it is already downloaded. So when you will download it, just search Anaconda prompt, give your file location, press enter, write Jupyter Lab, press enter. It will navigate Jupyter Lab into my browser. I will wait for a few seconds. So I will choose this. I will rename this. I will write feature, scaling, scaling, normalization. Okay. Press enter. Now import some libraries, some required libraries. NumPy, import pandas SPD, import matplotlib.pyplot as PLT, import cbond as an SN. Okay, hit the enter. I will take a variable data is equal to pd dot read. Here I will give this. This is our seventh lecture. I will copy path into the. I will check my first three rows just to ensure my data is loaded or not. Okay, so my data is loaded. Now I have to basically apply normalization for these two columns. So what I will do, first I will separate these two columns. Okay, suppose I will write num calls. I have taken a variable and I will just give the name of these two columns. Okay, Whenever we will call it, I will write data. Okay. 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 Now, first I will plot a graph. Okay. I will plot a graph. I will directly num calls. Okay. This plot. I will give some subtitle before normalization. Okay. TLT dot show. Okay. See, see here. Don't look at the this graph. Okay. See these values 400, 350, 300. What we need to fix is this, not this. Okay. So you don't need to basically see the bar graph, sorry, bars and all. Okay. Just see the values. Okay. Now, how we can apply normalization? For that, I will need to import min max scalar for normal normalization dot preprocessing from preprocessing module of scikit-learn import min scalar. Right? Yeah, min max scalar. Okay. Oh, sorry, this is a spelling mistake. Okay. Now I will create an object to call my min max scalar. Okay. Scalar is equal to uh, with tab min max scalar. Okay, I have created an object to call min max scalar. Shift plus enter. Now I will just copy my uh, actual data into a new variable data dot copy. Okay. Now data I will test it. I will sorry I will call num calls for those columns num calls for height and width which I have taken in num calls. I have to perform normalization. So I will call num calls directly is equal to this is the object through which I am calling min max scalar. So just write scalar dot fit transform data num calls, right? So again, fit will basically fit will basically learn the unique values, all the unique values in heights and width, and transform will basically scale the data. Scale the data means it will convert it like in 0, 1, 0, 0.25, 0.3 like this. Okay. So shift plus enter. Now I will check my data scaled. See, see height and weight column. First see here the height and weight column 1.62. This was the actual data set in which I had the values in height and weight columns like this. And now after normalization, look at the values. it has scaled the values of height and weight. Okay. Now I will plot a graph. Data scaled numpulse dot is plenty dot stop title right after normalization. I will give the title after normalization. Okay. PLT dot so see now look at the values. Now look at the values 0, 0.25, 0.50, 0. This is the values. And look at here. Here is the values were 1.6, 1.8, 2.0, 50, 100, in 150, in weight column 50, 100, 150, and in height column 1.6, 1.8, 2.0. Now look at the values of height and weight 0.00, 0.25, 0.50, and 0.00. So it has converted, it basically scaled the data. Okay, scaled the data. So this is how normalization works. In next video, we will see feature scaling using standardization. Okay, thank you. Hello guys, welcome to the channel. Today we will discuss feature scaling using standardization. In my previous video, already I explained what is feature scaling and how to do it using normalization. Feature scaling means bringing all columns to a similar scale so that no other feature dominates other. Okay, which means suppose I have age column 18 to 60, salary column 20,000 to 1 lakh. When we will build machine learning model and when we will use some algorithms, then it will give more importance to this because this column has the value like 20,000 to 1 lakh, which is much higher than this value. So it will give more importance to this, which is wrong in our case. So to counter this, in previous video, I used normalization. It basically scales the data to 0 to 1 form. Okay. So in this video, we will discuss how to perform feature scaling using standardization. Okay. Standardization is also a method of doing feature scaling, which brings all columns to the same scale. Okay. It converts data so that mean becomes 0 and standard deviation becomes 1. So it uses this mathematical expression z is equal to x minus mu upon sigma. Is your original value. Mu is equal to your mean, and sigma is your standard deviation. How much data is deviating from the mean value? X minus mu gives the distance between the mean value and the your actual value. Okay, so why do we use standardization? Suppose I have two columns in my data, height and weight. In my height column, there are values 1.5 to 1.8, and in weight column, I have values like 50 to 90. When you will use logistic regression, SVM, KNN for building machine learning models, then it will give more importance to this weight column because weight column's value is much higher than this. So it is wrong in our case because both columns are useful for us. Okay. So to counter this problem, we will use standardization in today's video. First, look at the data. In this data, I will basically scale the data of these two columns using standardization. Okay. I will show you how we can do it using Python. So for Python, And for coding purpose, we will use Jupyter Lab. Please download Anaconda Navigator. In my system, it is already downloaded. When you will download Anaconda Navigator, just search Anaconda prompt. Just search Anaconda prompt. Type cd. Give your file location. Give your file location. Control V. Enter. Write Jupyter Lab. Press enter. Navigated Jupyter Lab into my browser. Good. I will rename this. This is my eighth lecture. Eighth lecture. Feature scaling standardization. Okay. Center. First, I will import some required libraries. Import NumPy as NP. Import Pandas as PD. Import matplotlib. Matplotlib dot pyplot as PLT for plotting some graph. Okay. So first I will do. Okay. df is equal to pv dot read as CSV because I have CSV file. If you have Excel file, then write Excel. Just right click, copy path, Control V, check your data using by seeing first three rows. Okay. So my data gets loaded, and these are my first three rows. Okay. So I will first copy my data into a new variable first, just to show you by plotting some graph. Sorry, copy. Okay, I have copied this df data into df before. Okay, now I will perform standardization for these two columns. Okay, first I will import sorry from Scikit-learn dot preprocessing import standard scalar. Okay, press enter. Plus enter. Now suppose I will make a object to call standard scalar. I have made an object. Okay. Now which columns I want to basically scale, height and weight. So I will just take df double braces, square braces, height and weight. Okay, is equal to. I will call my object to call standard scalar dot fit transform transform df. I will just copy this. Okay, So what we are doing here, I'm calling standard scalar to fit for these two columns. Okay, it will scale the data for these two columns. Okay, so fit means it will learn the unique values of all unique values of height and weight, and transform will transform these values, or we can say scale these values into 0 to 1 form. Okay, so just the plus enter. Okay, now suppose I will write, I will check my DF. Now see your height and weight column. It has basically scaled the data. Now here it has value. It had values like this, height and for height and weight. Now see the value it has scaled for height and weight. See, these are my new values. Okay, it basically scaled the data. Now my algorithms will treat both columns equally. It will not give more importance to any column. Okay, it will treat equally to all columns. I will I will show you by plotting a graph also before and after. DF before, because I have not interrupted DF before. I have copied directly DF data into this. Okay, so my DF data is affected, not DF before. Okay, suppose take height column, height and weight column. Okay, plt.x label, height. Same I will give for y label. Weight. Okay, I will give a title for my graph before standardization. Okay, before standardization. Before. Okay, now plt dot show. See, but don't look at this. This is your just value. Look at these values: 160, 140, 120, 100, and look at this: 1.5, 1.6, 1.7. Okay, now I will plot a graph after standardization. Okay, so I have standardization in DF data. So I will just edit this by DF from DF before. Okay, and I will write after standardization. After standardization. Okay, got it. Now look at the value: 3210 minus 2 minus 101. Okay, so this is how values get changed. Okay, it has scaled our both columns. So this is how standardization works. Okay, so that's all in this video. Thank you. Hello guys, welcome to the channel. Today we will discuss function transformer. So what is function transformer? A function transformer is used to apply any custom mathematical function on your data. In simple words, if you want to change your data using your own formula, use function transformer. What it means? Suppose suppose I have a column passenger ID. Okay, and I have these values in it. Suppose I want to add a custom method, like every value should be divided by 100. So we can apply this method using function transformer. Okay, so why do we use it? Sometimes data is skewed, values are too large, relationship is non-linear, and these are the function we can apply, or we can apply our custom formula. Okay, now real life example. Suppose I have values like 1,000, 2,000, 50,000, 1 lakh values in a column. So these are much higher values. So after function transformer, we will basically make it smaller. Okay, we have reduced the values. Okay, so now after this data will become balanced. Okay, so I will show you how we can do it using Python. For coding purpose, I will use Jupyter Lab. For Jupyter Lab, please download Anaconda Navigator and then search Anaconda prompt here. Anaconda prompt, write CD, give your file location, Control C, Control V, enter, write Jupyter Lab. It will open Jupyter Lab into my browser. I will wait for a few seconds. I will choose this. I will rename function transformer. See, our first goal is to reduce these values. Okay, so for that we have already default function in our function transformer. I will show you that default function, and then I will show you by creating our my own function and how to call that function using function transformer. I will show you both. Okay. So first I will import some libraries. Import pandas spd. Import matplotlib.pyplot as plt. Plus enter. Now I will load my data set. df is equal to pd.read slash csv because I have CSV file. I will do copy path, paste here. Now I will check my data is loaded or not by checking first three rows. df.add. So my data gets loaded and these are my first three rows. Okay, so I have to reduce these numbers and I will do this by using a default function of function transformer. So first I will show you the default function. Okay, now from scikit-learn dot preprocessing, I will first import function transformer. Function transformer. Okay, now I will create an object. Suppose I will create log transformer is equal to, I will call function transformer by this object. Now I have to give the function name here. I will use a custom function. Sorry, I will first use a default function. Click Shift plus Tab. Now you will see this is our uh, default function to basically reduce the values. Okay, I will use this first. Control C. Control V, plus enter. Now want to use this function for this column. I will take that column from df data, take this column, Control V. I will call my object dot fit transform. Now, which is I am fitting passenger ID column. Give your passenger ID. Okay. Now set plus enter. What we have did here? What we did here? I have fit means it will learn all the unique values of passenger ID and transform will basically transform these values into a smaller values. Okay. Now check your DF data. Now see the values of passenger ID here and here. 892, 893, 894, and here. See here. Okay. So this is how we use custom method to reduce the value. Now I will show you how we can use our own custom method. Okay. Now suppose I will create my own custom method. Custom function. Custom. Suppose I will create this. Now suppose I want to divide all the numbers, this number by 100. Okay. Return return x return 100. Okay. This will be my custom function. Okay. I have created. Now I will call the function transform by creating an object is equal to function transformer. Okay. Now I will give the function name is equal to this custom function I have created. So I will give this name control. Okay. Now set plus enter. Now I will do the same process. Control C, Control V. I will change the object name because this is my new object of custom function. I will call this. Okay. So now you will check DM. Sorry. Suppose I will give a new name. Okay. Let's go. Now see this passenger ID have reduced these values using a default function. This one. It reduced these numbers by using this function of function transformer, and then I use my own custom function to divide this passenger ID by 100. Okay. So this is your passenger ID custom, which is used. I have used for my custom function of function transformer. So this is how we use our custom function and default function of function transformer for doing different things. We can reduce the number. We can apply my own custom method. Divide by 100, divide by add by 5, anything we want. So this is how it works. Custom method or default method of function transformer. Okay, so that's all for this video. In next video, we will see feature selection. Okay. Thank you. Hello guys, welcome to the channel. Today we will discuss feature selection. So what is feature selection? Feature selection is choosing only the important column or features for your model instead instead of using all columns. We keep only those that actually help in prediction. What it means? Suppose suppose I have this data set and this is an example of classification problem. Okay. Now these are my input fields and this is my output fields. Okay. Based on these input fields, I am getting the value for my output field, right? Now suppose I got to know that this field is not affecting my output column too much. Okay. So what I can do, I will simply drop this instead of going forward with this column for building models. So how will I got to know that this model is not affecting my data output data too much? Using feature selection. Okay. So why do we need it? It removes the irrelevant features, means columns, reduces overfitting, improve model accuracy, and makes model faster. Okay. Now, how to do feature selection? There are two methods using select k-base, using random forest. Basically, we generally prefer random forest. But yeah, these are two methods. I will show you how to do feature selection using these two methods using Python and Scikit-learn. And for coding purpose, I will use Jupyter Lab. For using Jupyter Lab, please download Anaconda Navigator. When you will download it, just search Anaconda prompt here. Type cd, give your file location, copy this, paste here, write Jupyter Lab. So it is opened in my in my browser. I will choose this. I will rename this. I will write feature selection. I will import some required libraries. Okay, so plus enter. Now I will load my data set. This is my data set. I will copy path, include B. Check your first three rows. Data is loaded or not. So yeah, my data gets loaded and these are my first three rows. Now, so first I will divide my data set into two parts. First for all input columns and one for output column. Okay. Now suppose in my X variable, I am taking all input columns. Give me the whole data set, but drop this column. Okay. This is what I am doing. I am taking all the columns, but I am dropping my output column. Okay, and in my Y column, I will take my output column. Okay, so I've divided my data set. Now, first I will check correlation of all columns. So it gave me the correlation between all columns. First, I will show you by plotting a graph. Okay, I will plot a heat map. Now, see the last column. So rotational speed RPM is in negative. So it is basically harming our my model accuracy or my output print. Okay, 0.24 quite good. 0.12 again it is less affecting my output print. 0.39, 0.39. So these are the two fields which are mainly affecting my output fields. Okay, this is what I got get to know from my graph. Okay, now how to perform how to perform feature selection using first method using select k-best method. Okay, now first I will import select k-best method sklearn dot feature selection select k-best and f classes. Okay, if you have uh, basically regression problem, so this I have this is a classification problem, so I am taking F classic. If you have regression problem, then you can import F regression. Okay. Now plus enter. Now I will make an object to call my select k-best method. Score function is equal to F classic, comma k is equal to I'm taking 3. Now what we are doing here, I'm I'm basically making an object to call my select k best. Select k best basically select top k features. This select this k features. It will select top k features. Okay, k is equal to 3. Now f is equal to classic. Basically f classic basically it is a statistical test for classification. Okay, F classic means. And K is equal to 3 means select top three columns or top three features. I'm using select K best method. So basically give me top three features. Okay. This is what I'm saying by this line of code. Now, Now suppose I'm taking a new variable, selector. I will call selector fit transform. I will transform now. Now, what it means? Selector fit means it will learn which values, which columns or features are most important, and transform means only keep those important features. Okay. Now, shift plus enter. Now I will take a new variable, selected features is equal to x dot column. I will filter my x column, which is my input columns. I will again call my selector object, get support. Okay, get support. So basically, it returns true or false for each column. Means this is my most important. This is affecting my data too much. Yes or true. This is not affecting my data. False. This is what get support do. Now, now I will see my selected features. See, it gave me top three features which are affecting my output data too much. See, 0.24, 0.39, 0.39. These three features have the highest values, right? Torque, NM, TWF, PWF, right? So it gave me top three features, right? So we got our three columns, top three columns which are affecting my output data. So this is the first way of doing feature selection using select key based method. Now I will show you how to do it using random forest. Okay. Now I will first import Scikit-learn dot ensemble import random forest classifier. So again, it is my classification problem. So that's why I'm importing random forest classifier. If you have problem of regression, then you can use random forest regressor, regressor. Okay, got it? Now I will make a object to call my random forest classifier. Okay, shift plus enter. Now I will fit my XY columns. Sorry, XY. Okay, it get fitted. Now suppose I will make a column. Sorry, variable model dot feature importances. So what I am doing? I'm calling my random forest classifier through this object model which I created dot feature importances. After training, this I have trained. After training, model gives importance of each feature. That's what I'm doing here. Okay. Now shift plus enter. Now I will make a new variable feature importance. I will make this into a readable format. Series importance, importance, index is equal to x dot columns. Okay. And converting important values into readable format, and index is equal to x dot columns means attach each feature names. Okay, that's what I am doing here. Dot index, small x. Okay, suppose I will call this. So it gave me, okay, it gave me the values, right? This torque have the good value 27, 0.13. Okay, so it gave me the values. Okay, now suppose I will make a graph value ascending is equal to false. I will make it higher to lower. Dot dot plot and is equal to bar. I will plot a bar graph. See, so see, it is showing this column is affecting my output data too much. Then torque, then rotational speed, RPM, then TWF and PWF. Okay, so it sorted in higher to lower. So this is saying this column is affecting mostly into of my output field. Then this is affecting more than this and then this. So this is my most important column for my output data. So this is how we do feature selection using these two methods, select k-based method and using random forest. Okay, so I have shown you all two methods of doing feature selection. So that's all in this video. In from next video, we will start supervised learning. Okay, thank you.